Good morning, students. Welcome to online lecture series of distributed computing system. In previous lecture, we have studied what is a multicast communication, what is marshalling and marshalling, what is data, external data representation. Now, in today's lecture, we will study the overlay networks. Then, what are the advantages of this overlay networks? Then, a message passing system. So, we'll see one by one. So, in overlay network, the concept of this network virtualization refers to the construction of several virtual networks over a present network. Today's this worldwide largest network, internet, is a classic example of the same. In a distributed system scenario, a separate virtual network is designed for individual distributed computing applications. An overlay network is ultimately a virtual network that the nodes and virtual links and is placed at the top of the fundamental network. The overlay network offers specialized services like routing in ad hoc network, content distribution, and multicast communication. So there are a number of types of this overlay network. That is first one is distributed hash table. Second is peer-to-peer file sharing. Then content distribution network, and wireless ad hoc network, then multicast, resilience, and security. So what is this a distributed hash table? So distributed hash table is a kind of overlay network that works on the basis of standard concept of a hash table in network scenario. In peer-to-peer file sharing, it supports the use of files by constructing a tailored routing and addressing mechanism. The next, content distribution network. These content distribution networks are dedicated for performance improvement in underlying network in order to supply the best content delivery facility to the web user. Then wireless and ad hoc network offers a tailored routing protocols in wireless and ad hoc network. The disruption tolerant networks. Or disruption, or instead of disruption, we see that there was this multicast overlay network. This multicast overlay network offers the access to the multicast services in case multicast routers are not offered. Then resilience. So resilience networks are dedicated for working on obtainability or accessibility of internet path and strive for the robustness. Then security. The security network provides higher level security in existing network. This is what another type of this overlay network is a disruption tolerant networks. So this disruption tolerant networks also provides the facility to existing network in order to make it capable of effectively functioning in aggressive surroundings. Then what are the advantages of these overlay networks? So investigation and experimentations with network services are permitted. The next, the network service customization can be done for the specific group of distributed application in a distributed computing scenario. New networking service can be announced and defined without making any modification in the fundamental network. The Skype, a software developed in Kazakh in 2003, is a classic example of your overlay network, and is basically a peer-to-peer software application meant for provision of voice over IP. The Skype is based on peer-to-peer architecture consisting of end users computing system and supernodes. These supernodes in this scenario are normal Skype hosts. A login server is used for authentication and authorization for the Skype. After successful login, a particular Skype user may connect with the supernode. The Skype establish a voice connection between two users with the help of TCP for signaling call request. Either and can say either TCP or UDP can be used for the streaming volume. So these are the different advantages of this overlay networks. Then message passing system. The message passing communication, these paradigms, a theoretical communication is a theoretical communication pattern. So different processes in distributed system communicates by means of message passing mechanisms more willingly than the communication through shared data communication paradigms. So message passing system is a subsystem, or message passing system is a subsystem of a distributed operating system that offers the set of messages based inter-process communication protocols. The message passing system allows process to communicate by passing a message between the respective processes. So there are some features of this message passing system. First is the simplicity. So what is simplicity? So a message passing system must be straightforward in order to build a new application and to communicate with already existing application with the help of primitives provided by the message passing system. It should be a simple and easy to use. Second one is uniform semantics. So what is this uniform semantics? The message passing system may be used for two types of inter-process communication in distributed system, either local communication or remote communication. So this local communication, that is communicating processes are on the same node. It is a local communication. What is this remote communication? Communicating processes are on the different nodes. The semantics of remote communication should be near to those of a local communications. This is very important constraint in order to ensure that a message passing system is easy to use. The next is efficiency. So efficiency is a serious issue for a message passing system to be tolerable by the users. Tolerable by the users. So there are some optimizations assumed for the efficiency. See, so these are as follows: as reducing the cost, maintaining the connection between different processes. Second is avoiding the cost of launching and terminating the connection between the same pair of processes for every message conversation between respective processes. That piggybacking of acknowledgement of preceding messages with the next subsequent message throughout the connection between sender and the receiver that contains several message conversation or message exchanges. Then fourth feature is reliability. So good message passing system must have the inter-process communication protocol to support the reliability features. So duplicate message are one of the issue associated with the reliability. The next fifth one is correctness. The message passing system has inter-process communication protocol for group communication. IPC protocol allows a sender to send a message to the cluster of receiver and receiver to receive the message from the several senders. So here atomicity, order delivery, and survivability are some issues related to this correctness feature. So what is this atomicity? This confirms that each and every message sent to the group of users will be delivered to either all of them or nobody of them. But this order delivery is ensured that the message reach at all the receivers in order to suitable to the application. Survivability. This guarantees that message will be transported suitably despite a partial feature of the processes. So next features of this message passing system is flexibility. So inter-process communication protocols of a message passing system must be flexible in order to supply a different nodes of a various application. Inter-process communication primitives must also have the flexibility to permit any kind of control flow between cooperative process, including synchronous, asynchronous, send or receive. The next is the security. The security defined as a state of being secure or protected. A good message passing system must provide a security for all message passing communication. A step necessary for secure message passing communication includes the following: authentication of the receiver of the message by the sender. Then second, that authentication of the sender of the message by its receiver. Encryption of the message before directing it over the network. The last feature of the message passing system is portability. So what is this portability? The message passing system should be itself be portable. So application written by using the primitives of the inter-process communication protocols of the message passing system should be portable. So these are the different features of this message passing system. The next, message passing interface. So message passing interface first announced by the MPI forum in 1994. So we know that two basic operations, namely that is send and receives, are used in message passing mechanism for proper communication and coordination. There are four different kind of send operations available in message passing interface: a generic send operation, synchronous send operation, buffer send operation, and ready send operation. These four send operations are furthermore categorized on the basis of blocking and non-blocking operations. So in case of generic send operation, MPI send, or can say blocking, and MPI send, that is non-blocking operations are there. So with this blocking operation, the application buffer of a sender can be reprocessed and reused, while in non-blocking returns the call instantaneously and communication request handle is given to an application program. In case of a synchronous send operation, this blocking and non-blocking operations are there. Okay? So this in blocking, the sender receiver synchronizes and the call, the return, when the message gets delivered at the receiver side. While in non-blocking operation indicates that whether the message is received at the receiver side or not. In case of buffered send operation, again there is a blocking and non-blocking operations are there. By means, that is, in blocking operation, the sender assigns MPI buffer library and returns the call when the data effectively gets copied into the buffer. While in non-blocking operation is used to check whether the message has been copied into the MPI buffer of a respective sender or not. And in last top, that is ready send operation. Here again, in blocking and non-blocking operations are accessible. Both operations are dedicated for indicating the ready to receive guarantee at the receiver side. So this is the last topic is over. So we stop here.